right, 3.4. So 3.2, we did addition, right? 3.3 was subtraction, and today's multiplication. And then when we get to the last section, it'll be division for whole numbers. Multiplication of whole numbers, kind of like when we did the other ones, we're going to start with what does it mean. So for finite sets A and B, if the number of items in set A is A and the number of items in set B is B, when n is not equal to 0, when we say n times A, we mean A added to itself n times. If n does equal 0, then 0 times A is 0. And if we're multiplying A times B, then it's the same thing as finding the number of items in that cross product thing that we had done before. We did this before, right? With the ordered pairs, it's the same thing. So we had the number of items in A times the number of items B is the number of items in the cross product A cross B. Okay, Cartesian product. Sorry, similar notation, different class. Okay, everybody good? Okay, so what we're going to look at next is we're going to look at the models for multiplication. And this is kind of like what we did with subtraction. I'm going to introduce you to these different models. These are to sort of give you some idea about how we really use multiplication and how we form questions about it, so that we can kind of get at when kids do and don't understand certain aspects of what multiplication is used for, okay? So model number 1 is the repeated addition model, and here's an example of a word problem or an application problem that shows that kind of an idea. Giselle takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? The reason this is a repeated addition is because it's happening repeatedly, right? The same number is happening repeatedly. So she takes 3 tests one Friday, 3 tests the next Friday, 3 tests the next Friday, and 3 tests the next Friday. Now, we're not really interested in doing the addition problem here, but we do need to understand that that's really what's being described. So the multiplication component of this then is that we have 3 times 4, and we would have 12 tests. So one of the ways that we actually have application of multiplication is this idea of repeatedly doing something over and over again. Second application is an array model. An array model is used for sets. And I mention that because the next one we're going to be doing is not. Okay, this is used for sets. Menu is baking cookies. He is able to place the dough 3 cookies wide and 6 cookies long on his pan. How many cookies will his pan hold? So there are quite a few objects, and you'll have an opportunity to talk about it with your people here in just a second, that actually present themselves in arrays. Like when you think about them like this. And cookies on a pan is one of them. We made cookies at my house earlier this week. And when we placed the cookies on a pan, 3 is what fit along each of the rows that I was doing, okay? So if we're drawing a picture of what this looks like, it looks something like this. It says 3 wide and 6 long. So we have 1, 2, 3. So this is 2 long, 3 long, 4 long, 5 long, and 6 long. Okay, notice this is not repeated addition. I didn't bake 3 cookies today and 3 cookies tomorrow and 3 cookies the next day for 6 days, right? That's not what happened. I placed them in a certain arrangement so that when I look at the arrangement, I recognize multiplications being used. So there are 3 cookies wide here. There are 6 cookies long. Whether you use words like long or wide doesn't really matter. But this is 3 times 6, which would give me what?
18.
18 cookies. Very good. Okay. So I'll refrain from giving you more ideas of arrays and let you guys explore that for a sec when you do yours. And then I'll come back to it and mention some other things that maybe you hadn't thought of. Okay, the third model for multiplication is an area model. An area model is often confused with an array model. Both of them are looking at length and width. But an array model looked at sets, and an area model looks at space. Okay, measurements. So here's an example. Alexis is planting a garden. She has a space that's 5 feet wide, not 5 plants wide, right? 5 feet wide and 7 feet long. how much area does she have in which to plant? So when we're looking at this one, we're talking about a rectangular shape, and it's 5 in one direction, and it's 7 in another direction. Now, we could draw this in like grid style. You could do that, right? So we could actually split this apart and make it 5 individual feet, like so. Right? And then 7 feet this way. Okay, that's not terrible. And you could literally count it, right? But each of these boxes is space. It's not an object, right? The cookies were an individual object that was in that spot. This is the space that we're actually looking at itself. So when we do this, we end up again with a multiplication, 5 times 7, which is 35. Do be careful because we actually are counting space here. It's not just feet, it's square feet. Or feet squared is how we write it like that. We read that as square feet. So there's 35 square feet of area. I think there's one more. We're on the next page, right? Yep. Okay, the last one is the Cartesian product model. And this kind of harkens back to our definition we saw at the beginning slide that had the cross on there, right? The A cross B. Okay, so this is used when we're ways of choosing options. Okay, this is another place, and we've actually explored it a little bit in some of the things we've already done this semester, but this is another place where we are doing a different type of problem. It is worded differently. So here's an example. Unique is at a pizza place. She can choose from 2 types of crust, thin or original, and 3 types of toppings, pepperoni, sausage, and ham. How many different types of pizza could Unique choose? So I don't know if I have a space on this. I do. Okay, so I'm going to go to the next slide just for space, but you've got space on your paper itself. So the original choice that Unique is making is she's making a choice in the type of crust. What are her 2 types of crust?
Thin or original?
It's thin or original. Now, if you've taken proportional and statistical reasoning, this might be something you've seen before. If you haven't, it's not a problem. It's just, it comes back up in that class too. So we have 2 choices to make in terms of the pizza crust. And then once we choose the pizza crust, let's say for the moment we chose a thin pizza crust, then we have 3 more choices, right? What are my choices?
Pepperoni, sausage.
Pepperoni, sausage, and ham, I'll abbreviate. But we have those same 3 choices if I choose an original crust, right? So down here as well, I have pepperoni, sausage, and ham. And if you look at the end of this, right, you sort of follow along the diagram. It's almost like a flow chart too, right? Kind of an imagery. You can see at the very end, there's been 6 different kinds of pizzas that have been created, right? They all are different. They either are different in the type of the crust or they're different in the type of the topping. So there are 6 over here, different types of pizza. Okay, there's 6 different types. And again, we do this because it's 2 times 3 that's happening. So this has to do with choices of things being made. So when I teach a similar concept of this in my proportional and statistical class, I talk about getting dressed in the morning, and you have like your shirt and your pants or whatever, a certain number of tops, certain number of bottoms, and you can arrange them in any way. It's the same thing. I'm making choices. So there's lots of things you can do for making choices. So I want you to take the next 5 minutes or so within your group. I want you to come up with 4 word problems and be prepared to share at least one of them aloud to the group, okay? 4 different word problems, one for repeat addition, array, area, and Cartesian product. Okay, somebody tell me what your repeated addition word problem is. Okay, Macy.
Izzy works 4 hours every Thursday. After 5 weeks, how many hours does she work?
Perfect. 4 hours every Thursday, and how many does she have after 5 weeks? Miranda, I saw your hand as well. Do you want to read yours?
Oh, sure.
Okay.
Johnny has ballet classes 3 times a week for 3 weeks. How many classes does she?
Excellent. So we have classes happening 3 times in a week instead of talking about a specific amount of time per day. That works as well. Very good. Okay. Next one, array. Who wants to do their array model? All right, Brooke.
One side of a Rubik's Cube is 3 squares high and 3 squares wide. How many squares are on one side of a Rubik's Cube?
Perfect. Can you picture that as an array? Very nice. Okay, how about another array? What do you have?
Marcus is creating an eyeshadow palette, and there are 2 rows. Wait, no, I don't get that. That's mine.
There's 2 rows of 6 shades. How many shades are there?
2 rows of 6 shades in an eyeshadow palette. I have to say I have never heard that used as an example. Thank you so much. Wonderful. Just out of curiosity, what kind of other things did you guys think of as arrays? Just what object are you using?
A garden.
A garden. You can actually talk about the specific plants in the garden, right? Yep, you can do that. What else? What was that? Brownie squares, so that our baking kind of an idea as well. What about donuts in a donut container? Perfect. Food's a good example of these. How about things like soda cans?
Elephants.
Elephants? I
Elephants.
gotta know how the elephant, are they walking in like a row or something?
Yeah.
Okay, so we have like a 2x3 rows or something like that.
Yeah.
Okay, that'll work. You can also do classroom desks. This is not a good example because you guys are all shifted around. But typically when you walk into the classroom, we've got a number of rows and columns and they're about even, right? You can do that. So there's lots of examples. How about area? I have 2 groups that haven't talked to me yet. Who wants to do area? Neither of you do. That's not good. Did you guys not get to area, Kiki?
I can.
Okay. What do you have,
The shed
Jazzy?
is 20 feet long and 18 feet wide. Where's the area?
Okay. What was it? What was the original object?
The shed.
The shed. Okay, so the shed's length and the width of the shed. Okay, good. What did you have?
For area,
Yeah.
I said Justine corrals her donkeys into her fence. The fenced-in space is 15 feet wide and 20 feet long. How much area space do her donkeys have?
Excellent. We have donkeys in a pen. That's fantastic. Okay. The last one. Everybody said something at least once, so whoever would like to. Who would like to do Cartesian product? Yes.
Okay, Sally wants ice cream. Her flavor choices are chocolate or vanilla, and her topping choices are sprinkles, cookie crumble, or caramel syrup. How many combinations are there?
We should all go with RJ to eat ice cream, shouldn't we? That sounds fantastic. Good job. Okay, yeah. Ice cream flavors and toppings. That's wonderful. One more for Cartesian product. Somebody volunteer.
that.
All right, what do you have, Sydney?
We have, I don't know. Wait. Tom has to choose between food and flowers to plant in his garden. Food choices are tomatoes, potatoes, and cucumbers. And flower choices are tulips, poppies, and orchids.
Okay, and the one thing that I would add to that then is that he has to actually choose one of each. So he's going to choose one object in the plant category and one object in the flower category, and then that'll work great. Vegetable category and flower category, that's what I meant to say, and then that'll work great. Yeah, so we're choosing objects to put in our gardens. Okay, does that make sense? Right, if a kid only thinks of multiplication as only one of these types, and they encounter a different one of these types, they're not going to understand that this too is multiplication, and all of these are multiplication problems, right, that you guys created. All of them were. Okay, let's take a look at whole number properties for multiplication now. So some of these are properties we've seen before that are now applied to multiplication, and there's a couple new ones in here as well. So the first one you've seen before, closure for all whole numbers. If you multiply 2 whole numbers together, you get another whole number. Now we saw that worked for addition and whole numbers, but we've also seen some examples where it didn't work. Like if you add an odd number, you don't get an odd number, so that's not closed. Okay, so again, whole numbers with multiplication work. But also there's other things with multiplication that work and some that don't. Okay, so multiplication as a general statement is the thing that we can try to use to see if we have closure. So you'll see some more questions about closure, which I know were your favorite. And so you're going to explore that just a little bit more. Commutative. Commutative property says that we can multiply in any order. And again, you guys do this when you first learn to multiply in that 2nd, 3rd grade time frame. Is that you do your multiplications by maybe ones first, and then you do your multiplications by twos. But at some point when you get to multiplication by 7, you don't have very many more to learn because you've already done 1 times 7 and 2 times 7 and 3 times 7, and reversing it gives you the same value. So you've got the commutative property. Associative. Your associative property talks about the order of the multiplication staying the same. So it says ABC, ABC, but the groupings are changing. Now, grouping tells you what you do first, right? It's order of operations. We do things inside parentheses before we do them outside parentheses. So the order in which we're doing things is changed, but it's changed by the location of where the parentheses are placed. So no matter where the parentheses are placed, we get the same product. And again, that can be very helpful if there's 2 numbers that are easier to multiply together first rather than second. Identity property. So we mentioned we had an identity property for addition. This is the multiplicative identity property. And the reason I mention it as being different is because the multiplicative identity, that number, is different. What was our additive identity? It was 0. But our multiplicative identity is not the same value. It's the number 1. So the multiplicative identity is 1. And the reason that is the identity is because 1 times A, no matter what A is going to be A. And the order in which we do it doesn't matter. So if we do A times 1 or 1 times A, we get A. Do you have a question, Caleb? No? Okay. Is that good? So anytime you specify that you're using an identity property, you really need to tell me which of the two you're using. Are you using the additive one or are you using the multiplication one? Okay? Yep, RJ.
Was it back on the associative property if, okay, so what was it, the A times B in the parentheses and then C on the outside, is that was the distributive property?
We're getting to distributive. We haven't gotten there yet.
Okay.
We're close. I think it's the next slide. Yep, look at that.
Okay.
So hold tight. You're about to get that one answered. All right. One of the other reasons why I really want us to specify when we're using the multiplicative identity as instead of just saying identity is because there is a property for 0 with multiplication, but it's not the identity property, right? This is the multiplicative property of 0. And it says when I multiply 0 by anything, it zeroes it all out. Okay? So this works things out really nicely when you're trying to do some algebra and you're trying to plug numbers in and things become 0 and they cancel. It's very friendly. So the multiplicative property of 0 says when I multiply by 0, I get back 0. And then the last one is the distributive property. The distributive property actually merges multiplication with addition and or subtraction, one of the two. So when we have multiplication over here on the outside, this A, and then there's addition and subtraction inside, as opposed to being like multiplication inside, like there was in the associative property, what happens is we multiply that first value by each of our individual pieces, and you're probably familiar with drawing some sort of like arrows or arcs to remind yourself that you're doing that. So A times B is AB, A times C is AC, and then whatever the sign is between them, that is whether it's addition or subtraction, stays the same. Okay, so you're still in your groups, and we have 6 of these properties that you're going to take a look at and decide which of them that they are. Real quick question first, RJ, what do you have?
Okay, if the number, sorry, on the distributive, if it's on the other side, on the right side, would it
It's the
still-
same thing. Yeah, it doesn't matter because we can commute. So yes. So while it's written with the A on the left, if the A had been written on the right like this, it would still be the same thing. Yeah. Okay, so take a look at these 6 and decide which property is being used. And this is like what we did with addition. This is not like a one and done. You don't get to mark it out. It's not a test bank, where you just mark out the one you used. You could use something more than once or not at all, okay? So take a look at those 6. Do it yourself first and then compare in your group and see how your answers compare. You don't have to. It'll be fine. The only one that matters really because of the way it works differently is the identity. Let's take a look at what we have on these. If you didn't get quite finished talking, it's okay. We're just going to make sure everybody has the right information written down. What did we put for the first one? Yep, this is the multiplication property of 0. Or multiplication by 0 property, some version of that. What do you get on B? Yeah, it's commutative. And I heard some of you guys talking about commutative, associative. Which do we have? And we want to make sure that we understand that just because there's parentheses does not mean it has to be associative, or now we have distributive. It doesn't have to be one of those. This one is commutative because the order 7, 3, 4 is being disrupted. The 3 and the 4 are switching. So when we change the order of something, that's a commutative property. The parentheses are still around the same piece, the 4 times 3 piece. So this is the commutative property. How about the third one? Now we've actually changed the grouping symbols, what they're around. Very good. So this is associative property. How about the fourth one, D? Multiplicative what? There we go. This is the multiplicative identity property. How about E? Yeah, you're right, Ty. It's distributive. So this 5 right here is going over this. And in fact, RJ, this is exactly the same form that you were asking about, isn't it?
Yes.
Where the 5 was after it. You bet. So yes, this one would be the distributive property. And the most interesting one, or maybe the less direct looking one to what we've done, is the last one here. I heard some good conversation happening about this. Which one do you think this one is? It is distributive. It's a funny looking one, right? But they've taken the value at the beginning, this highlighted piece, and they've distributed it to each of the other pieces. So this also is the distributive property. Okay, we'll pause there for today.